Welcome to the presentation on the new mathematics curriculum. I am Givanath Sharma from the Department of Curriculum and Professional Development. In this presentation, we'll start with the overview and the structure of the mathematics curriculum. As all of us know, mathematics is the abstract science of number, quantity, and space, studied either as abstract concepts through pure mathematics or through applied mathematics through many disciplines. It is one of the subjects that students study from the pre-primary classes to class 10 and as an optional subject from classes 11 and 12. Mathematics as a subject provides a firm foundation to pursue mostly STEM-related subjects as well as other subjects. The focus of maths education is on enabling the learners to construct mathematical knowledge and transfer the knowledge. The goals of the school mathematics curriculum are to facilitate students to achieve the key competencies enshrined in the National School Curriculum Framework and the competencies specific to mathematics. Achieve the mathematical competency required to work in a society that is technologically oriented and information rich, either within Bhutan or outside. Develop the understanding of various mathematical concepts and procedural skills, ability to explore variety of strategies for problem solving, and the ability to think and reason logically to enable them to cope with everyday mathematics and mathematics required in the world of work. The other two goals are to provide a foundation for those students who may continue to study mathematics or other areas requiring strong mathematical background and also help foster and develop mathematical talent. And finally, to inculcate an understanding of the value of mathematics and its usefulness to them, to nurture confidence in their own mathematical ability, and to encourage a continuing interest in learning and doing mathematics. The key competencies that are targeted through the study of mathematics are twofold. One is the core competencies enshrined in the National School Curriculum Framework, and the other one is the competencies specific to mathematics. In the National School Curriculum Framework, the competencies that are enshrined are spirituality and values education, language, transversal competencies, enterprising and industrious, sustainable living, health and well-being, and digital competence. And the competencies that are specific to mathematics are communication, mathematizing, representation, reasoning and argument, and devising strategies for problem solving using mathematical language, tools and technology. The guiding principles for the development of this framework are based on the guiding principles derived from the National School Curriculum Framework. They are values, gross national happiness, inclusiveness, future-focused, dynamic and relevant, and student-centered and developmentally appropriate curriculum. To move on to the strands of the math curriculum, there are 5 content strands, namely numbers and operations, patterns and algebra, geometry, measurement, data management, and probability. And the 3 process strands. They are formulating situations mathematically, applying mathematical concepts, facts and procedures, and interpreting, reasoning, and evaluating mathematical outcomes. The next section deals with the competencies related to mathematics. In this, the first is the key stage-wise competency-based standards. The key stage-wise competency standards set the benchmark for each strand at a particular key stage. For example, for the number and operations strand, the following are the key stage-wise competency-based standards for key stage 1. So as we can see, we see strand A, numbers and operations. There are 4 key stage-wise competency standards to be achieved by students as they complete class 3, that is key stage 1. To achieve those key stage-wise competencies, we have the class-wise competencies. The class-wise competencies basically set the benchmark for each strand for a particular class under a particular key stage. The class-wise competencies lead to the achievement of the key stage-wise competency-based standards. Again, as an example, for the number and operations strand, the following are the class-wise competencies for class PP that will contribute to achieving the key stage-wise competency-based standards under this strand under key stage 1. There are seven class-wise competencies for class PP that will help to achieve the key stage-wise competency-based standards. Then we have the objectives. Objectives are set for each topic that is required to be studied under each strand to enable the learners to achieve the class-wise competencies under each strand. We see here the class-wise objectives for 2 topics, that is describing attributes of objects and sets for class PP. Then from the framework, we have designed the instructional guides for each class. This slide here shows the connection between the framework and the instructional guide. So as we can see here, we take a topic from the content. It could be 1 topic or 2 topics or related topics from 1 strand or more than 1 strand also. Then we identify what are the competency or competencies that topic contributes to. Then next, after the competencies are identified, then we identify the relevant objectives related to the topic or topics that contribute to achieving the competencies. Then from there, pedagogy is suggested for either contact teaching or non-contact teaching. So that's how the instructional guide is developed. Next, the teaching and learning approaches. The school math curriculum is grounded on the following learning principles and theories: experiential learning, inquiry-based and discovery learning, reflective learning, constructivism, cooperative learning. Therefore, as teachers, it becomes imperative to design lessons that support the learning of mathematics through the above mentioned approaches. However, I would like to make a mention here that these are not the only approaches that we can use in learning mathematics. Sometimes we can localize approaches that are relevant for certain topics. Next, we move on to some aspects of maths learning that are particularly relevant in the teaching and learning of mathematics. So, in the teaching and learning of mathematics, there are 3 distinct stages. One is called the informal learning, where it contains activities which afford opportunities that are experiential, practical, pictorial, or concrete. Second, we move on to something called pre-formal, that is wherein students undergo experiential learning by the use of representations, models, and concepts which are more efficient and abbreviated. Then finally, we reach the formal stage where it represents the targeted formal procedure. For example, in this task, at the informal level, students were given a task about survey activity. So they see some pictures there, some representations. Then from there, students move on to the pre-formal level, wherein students represent their analysis by using percent grids, which are appropriate with percentage grids that are required. Then from there, in the formal stage, students find the procedure to convert percentage to fractions or represent fractions as percentage. So students start from a very informal level and reach a formal level. All math learning are designed in that manner. Second, as teachers, what are some of the considerations that we need to keep in mind to design mathematics lessons? One, designing lessons that focus on knowledge construction and transfer. As all of us know, the focus of math lessons should be on guiding students to construct desired math knowledge using concrete, pictorial or representational and abstract approach that facilitates deeper learning of mathematical concepts. And the second one is help them to transfer or apply the constructed mathematical knowledge in familiar as well as new situations through experiential learning, problem-based learning and project-based learning. Next, we need to make provisions for making mathematical connections, representations and communication. Connecting mathematics within and across topics helps students to appreciate the interconnectedness of different mathematical ideas and the relationships that exist between mathematics and real life. Next, we need to design lessons that encourage divergent thinking by posing questions or creating appropriate situations. For example, asking box plus box is equal to 10 instead of asking what is 5 plus 5 opens up multiple possibilities that encourages students to realize that there are multiple ways of arriving at solutions to problems. And this is a very, very powerful life skill in itself. Next, we need to encourage reflective practices at critical phases of lessons to enable students to think about where they are in their learning and what do they need to do to reach where they need to. And the next aspect that we need to take care, which goes without saying, is embedding assessment and feedback into the lesson through meaningful assignments to assess learning of content, processes or the desired competencies. The next aspect that we need to keep in mind while designing lessons are the concrete, representational or also the pictorial and abstract strategy. In this there are three parts: concrete, pictorial and abstract. The concrete is the doing stage where students use concrete objects or manipulatives to model problems. In the pictorial or the representational stage, students see what that problem is, or they are able to represent the problem using pictures. And then the final stage is the symbolic stage where abstract symbols represent the objects in the concrete and or the representational and pictorial level. For example, to add 4 and 5 or to find the sum of 4 and 5, what we can do in the concrete stage is provide counters or manipulatives to students where they put 4 counters in one place and 5 in another place and then put them together and count, and they see it is 9. Next, they represent that using pictures, and finally they write that in abstract format. Next, we need to encourage divergent thinking that will deepen students' understanding of concepts. For example, what is 18 times 9? It's a very simple multiplication. However, we can ask students to explain how do they arrive at the solution. Students can arrive at the solution 18 times 5 is equal to 90 in a variety of ways. And that also indicates that in a class, thinking of the students could be different. And when we ask students to explain how they arrive at that, then they begin to reflect on how they understand a particular problem or a concept. At the same time, when they see the same problem being solved in a variety of ways, it helps them to deepen their own understanding. Second, this is an example of a problem where a student reads 3 times as many pages as another friend. Then the problem is saying, Briar read 15 pages of a book. How many pages did Kara read? And then the problem is solved in a variety of ways. It's solved by using modals, by using arithmetic, by drawing a picture, and using number lines. So the same problem can be solved in a variety of ways. This is a powerful skill that we need to communicate to the students right from a small age, because this is a powerful life skill in itself. Whenever they come across problems in lives, if they cannot solve that problem in one approach, they can always think of an alternative solution. Another example, students are asked to add 2 numbers, 138 and 29. So we give them a template and say, I can add by, and then some students can write, by finding friendly numbers. They estimate first and then add up the numbers. Then second one, I can solve by counting from the higher numbers. So 138 plus 29, 138 is higher, then 29 is broken as 20 and 9, and then the solution is obtained. Or since 29 is very near to 30, some students might want to do as follows: 138 plus 30 and minus 1, and that gives the solution. Or they can write in an expanded form and then get the solution. 138 as 100 plus 30 plus 8, and 29 as 20 plus 9. Add the hundreds, the tens, and the ones, and then finally add them all together. They can do the same thing by arranging vertically and then adding from left to right or from right to left. Or they can do that same thing by using manipulatives also. Represent 138 using base 10 blocks, and 29 also using base 10 blocks, and then count the blocks and write the solution. So in a variety of ways when addition can be done, when students see this, then their own understanding or the learning becomes deeper. Similar example again, multiplying 2 numbers. So they can multiply using rectangles. They can solve using expanded form horizontally, break that 100 into 100 and 20 and 7, and then multiply by 6. Multiply the 100 by 6, the 20 by 6, and the 7 by 6, and then add the individual results. They can show that vertically, aligned vertically in an expanded form, or multiply directly. So this is a template that we can use to encourage divergent thinking amongst the students while solving problems. This can be used for individual task or group task also. Next, we move on to the assessment of mathematics learning. So all assessment in mathematics should assess the achievement of competencies in each strand for a particular class, while students engage in formulating situations mathematically, applying concepts, facts, and procedures, and interpreting the result obtained with respect to the problem. The evidence from the assessment should be used to gauge how students construct desired mathematical knowledge and transfer the constructed mathematical knowledge in familiar as well as new mathematical situations. For this, we need to design appropriate performance tasks and tools to assess the achievement of the competencies. This is the assessment matrix that summarizes the requirement of assessment in mathematics. We can use a number of techniques, variety of tools, and then the frequency of assessment, and how should we go about recording that. For example, we have an example here. This is a class 5 topic. So class 5, the competency that the student needs to achieve by the end of the lesson is to demonstrate the ability to divide a 4-digit number by 1-digit number with or without regrouping. And the objectives that contribute towards achieving this particular competency are: use estimation to predict quotients, use models to divide and link to algorithms, develop personal and standard algorithms, and then explore divisors which are multiples of 10 only, 10, 20, 30, etc. These competency and the objectives are taken from the framework which is there in the instructional guide also. As we can see, the competency and the associated objectives require a student to estimate, link models to algorithms, and develop personal algorithms while dividing a 4-digit number by a 1-digit number. This is an example of a performance or assessment task to assess the competency directly. The assessment rubric is designed looking at the objectives and the competency. Again, I would like to make a mention here that this is not the only way to do so. However, for this particular competency and the associated objectives, this is one way of designing the assessment tools. So to achieve the above objectives, which will contribute to achieving the competency, we have the following assessment tool. So we have the criteria: reasonably estimate the solution, link models to algorithms, and then develop personal or standard algorithms. And then for each of these criteria, we have the levels of achievement. For example, under reasonably estimate the solution, a student will fall in the beginning category if the estimated solution does not make sense with respect to the solution, while a student will fall in the exceeding category if the estimated solution is about to or equal to the solution. Similarly, there are descriptions for the other two criteria. Then we need to design a task that the students will perform so that the teacher can use the tool to assess the student learning. So these are the tasks. There are 1, 2, 3, 4 tasks that the students will perform, and then the teacher can use the tool that is designed to assess the learning of the student as they complete the tasks. So this is how we can link this is an example to show how competency, objectives, assessment task and tools need to be linked so that we are able to assess what we need to assess. Next, we move on to the assessment weighting. Strand and key stage wise weighting. So for key stage 1, we know that it is continuous formative assessment. There is no weighting. For key stage 2, that is from class 4 to 6, under strand A, the weighting is 38%, strand B 14%, strand C 16%, strand D 17%, and strand E 15%. Similarly, for key stage 3, that is class 7 and then class 8, the weightings are given for different strands. This is also available in the assessment structure that is circulated to the schools. Next, we have the weighting for key stage 4, that is class 9 and class 10. The weightings for each strand for class 9 and 10 are slightly different. Then the next is the waiting for key stage 5, that is class 11 pure mathematics and class 12 pure mathematics, and then class 11 business mathematics and class 12 business mathematics. Please note that in the business mathematics, strand C and D are put together because of the nature of the topics that are available for them to study. Then the next part is the CA and the summative assessment breakup for each term for each key stage. So for key stage 1, it is CFA. We don't need to do any breakup there, but key stage 2, that is class 4 to 6, more marks are accorded to CA, first term and second term total up to 60%, and then for the exam it totals up to 40%. Similarly, key stage 3, the CA for first term and second term totals up to 40%, and then the examination mark totals up to 60%. Then for class key stage 4 and 5, for key stage 4, the CA mark for term 1 and term 2 totals up to 30%, and the examination mark totals up to 70%. And in key stage 5, the CA mark totals up to 20%, and the examination marks totals up to 80%. Please note that for each term, we need to assess each competency through appropriate performance tasks and assessment tools. The performance tasks could be quiz, question and answer, presentation, making models, small projects, etc. And then the assessment tools that we can use are checklists, rating scales, or rubrics. And then the areas of assessment that we can focus on is how do children formulate situations mathematically, how do they apply concept, facts, and procedures, and how do they interpret mathematical results. Then we need to convert all these to recording to get the CA marks. So what we need to do is, for all the key stages, the assessment shall be recorded based on the achievement per learning competency for each strand in 4 levels in the following manner during the teaching learning process. So this is a template that we can use: strand, content, topic, competency, then name of the child, and then the level of achievement. And then from there, using this template for each term, we need to convert and get the CA marks. So marks obtained for each strand and ultimately for each subject from the formative assessment can be converted using appropriate conversions for summative purpose. How we do that is by assigning scores to each level of achievement. That is 1 for beginning, 2 for approaching, 3 for meeting, and 4 for exceeding. And then we add up that. So we use the formula CA marks is equal to the sum of scores obtained for all the competencies that are covered for that term, and then divided by the sum of highest score for all the competencies covered times the CA for the term.